today we're doing the problem. A recreation program serves a total of 280 children who are either 11 or 12 years old. The sum of the children's ages is 3,238 years. How many 11-year-old children does the program serve? So the first thing we're going to do is we're going to assign variables for our unknowns. In this situation, we don't know how many 11-year-olds or 12-year-olds there are. So we're going to let x equal our 11-year-olds and y equal our 12-year-olds. We're going to write a system of equations to represent what's going on. So first thing we're told is that the sum of children is a total of 280. So x plus y should equal 280. The next thing we're told is if you take the sum of all the kids' ages, it's 3,238 years. So for every 11-year-old, one kid is 11 years old. If there's two kids, that's a total of 22. So we're multiplying x times the 11. So 11x plus every 12-year-old gets 12 years added to this total age. So we're going to do 12y, and that should equal 3,238. We have a system of equation, and all the system is that there's two equations, and both need to be true in order for the values to be true. So we have two options with how we solve our system. In this situation, I think it's appropriate to use elimination. So the first thing I'm going to do is I'm going to say that I wish this equation could cancel out with this equation. And again, my goal is to solve for my x value, so I'm going to do some multiplication to try and work towards that. The first thing I'm going to do is I'm going to multiply this whole entire equation by either negative 11 or negative 12. The reason I want to choose one of those two values is because when I add them, it will make these terms cancel out, one of these terms. I'm just going to do negative 11 because it's first. It seems easy enough. So when I do that, I'm going to rewrite. Negative 11 times x is negative 11x. Negative 11 times positive y is negative 11y. And this all equals negative 11 times 280. Let me check that really fast, is negative 3,080. So we've got all of that. We haven't done anything to this bottom equation, so I'm just going to bring it over exactly as it is. So now I still have two equations. This equation is equivalent to the first equation we wrote. And now I can add them straight down. So negative 11x plus 11x cancels out and becomes 0. Those terms are gone. Negative 11y plus 12y is just positive 1y. So I'm just going to write y equals negative 3,080 plus 3,238 is just going to become 158. Y has been solved for, and y was our 12-year-olds. So we know there's 158 12-year-olds. Now we know there's 280 children total in the program. So if our x value, which is our 11-year-olds, plus the 158 equals 280, then I can just subtract 158 from both sides and find that x equals 122. So preliminarily, I think that there are 122 11-year-olds, but I want to be sure. So we know that these values work for our top equation, but let's check to make sure both the values work in our bottom equation. So let's see. This is going to be our check. 11 times 122 plus 12 times 158 should equal 3,238. Now, if I do 11 times 122, I'm going to choose to do that in my calculator, and I get 1,342 plus 12 times 158. You can do that by hand if you'd like on some scratch paper, or you can do it in your calculator. You're going to get 1,896. When I add those two values together, I do indeed get 3,238. So it does check out. There are 122 11-year-olds in the program. If you have a math question or a homework problem you would like me to explain, add it in the comments.